When you enable multiple spanning tree protocol, every single VLAN by default will be placed into a very special spanning tree instance. This is known as the internal spanning tree instance, or instance 0. So as you can see here, VLANs 11, 22, 33, 44, 55, and 66 are all part of this instance by default. Notice the physical topology, and notice the logical spanning tree topology. The logical spanning tree topology is blocking this particular port right here, and therefore, for instance 0, that is the blocked port for all those VLANs by default. However, the goal of multiple spanning tree protocol is to create our own spanning tree instances and put VLANs into them. So in this example, they're creating MST instance 1, and VLANs 11, 22, and 33 have all been placed into MST instance 1. Notice the physical topology is the same. It's the same region we're in. However, the spanning tree topology, the logical topology, is still the same as well, because it hasn't been manipulated in any way to make that change. But if we look at MST instance 2, look what's going on with MST instance 2. We have VLANs 44, 55, 66, but the logical spanning tree topology has changed. So through the manipulation of the root bridge placement for the multiple spanning tree instance, we were able to change that spanning tree logical topology. So why is the IST instance, the internal spanning tree instance, or instance 0, so important? Well, it is only the IST that sends BPDUs. That's right. It's only the IST instance that sends BPDUs. There will not be a BPDU sent for each and every single spanning tree instance in this case. Just one BPDU is sent. And this BPDU is from instance 0. However, inside of this BPDU, there is very important information. And it is the information about the different MST instances that are contained within that MST region. And these MST instances are represented by M records. So the M records are going to describe the information that is necessary for all the different MST instances to build the logical spanning tree for each and every single one of those different MST instances. So we're reducing the amount of BPDUs that are going to be needed within the particular MST region based on having that IST instance, or instance 0, send that BPDU information. So what is going to be utilized to identify now the instance? Right, when you think about back, when you learned about spanning tree protocol or rapid spanning tree protocol, the bridge ID contained the extended system ID for what purpose? To identify the VLAN. But in this case, we don't have to identify VLANs. We have to identify the instances of spanning tree protocol. So now within the bridge ID, we will find, in this case, the MST instance number. So instance 1 or instance 2 or instance 3. That information is carried inside the bridge ID. And based upon the fact that the VLAN to instance mapping is locally stored on all the switches, then based on this instance number that's carried in the bridge ID, that can be compared to the database that has the instance to VLAN mappings, and the spanning tree topology can be built from there for all of the different MST instances.